Hello everybody, welcome to my video. My name is Riyad, and in this video I'm going to be demonstrating the very popular and known Cisco proprietary routing protocol known as RIP version 2. Now, what does RIP even stand for? And no, it does not stand for rest in peace. It actually stands for Routing Information Protocol. Now, when it comes to routing, there are mainly two types of routing. So the first type of routing is static routing. And static routing is done by manually inputting each IP route for each router. And if you really think about it, this can be very tedious when it comes to corporate environments, because imagine you have hundreds of routers. You're gonna have to, manually input each router, and then there's gonna be prone to a lot of mistakes. So we tend not to usually use that type of routing, but it's okay to use in small environments. Now, the second type of routing, which is the type of routing that we're going to be working with today, is known as dynamic routing. Now, dynamic routing is done with the help of routing protocols, such as RIP version 2, which is what we're working with today. So, RIP version 2 actually uses something known as distance vectoring. Now, distance vectoring basically counts how many routers it takes to get from the source router to the destination router. Now, let's use my handy dandy diagram over here and show you how that works. So let's say router 1 over here wants to get to router 3. So it can either take network 20.0.0.1 and go and travel there through there to get to network 20.0.0.2, or it can take the longer route, which is 30.0.0.1 to 30.0.0.2, and then from 10.0.0.1 to 10.0.0.2. Now obviously that's less efficient, thus the first route is the best route. So in the routing table for these Cisco routers, it's going to obviously use the first option because it's faster, right? It only takes one hop of a router instead of two hops. So now we're going to go into GNS3, and I'm going to show you how everything works in action. I'll see you there. Hello, we're back, and now we can see I'm in the GNS3 window, and I'm now going to walk you through the CLI commands that I used and explain how everything works. So let's go over on here to the right. This is all of the commands that I used to configure these routers. So let's just go through each one. The first one we have here is EN, which is short for enable. And the enable command in the Cisco router is basically allows us to go from executive mode to privileged exec mode. And what that basically means is it lets us have full access to configuring and changing router settings, such as setting up interfaces and all that stuff. Next, we have the conft, which is short for configure terminal. The configure terminal command allows us to access global configuration mode, and it allows us to modify a device's global configuration. Next, we have the hostname command, and it just sets up the router's hostname. In this case, we have my last name right here, and then router 1. And then we state the interface. In this case, 0/0, which is this one right here. And this is for router 1. So we state the interface that we want to configure. Then we use the IP command, which allows us to assign an address and a subnet mask to that interface. And then we use the no shut, which basically means is short for no shutdown. And it makes the interface state go from administratively down to up. And yeah, and then we just repeat it for the other interface, which is 1/0 right here. And we assign it this network. And yeah, so, and then I actually added a loopback address just for testing and management or troubleshooting and routing purposes. So it's always a good practice to do whenever you configure any kind of network or routers. And yeah, and then again, we have no shut after each interface has been assigned the IP address. And then this is how the router RIP configuration would work. So the first step is to use the router RIP command, which allows us to go into the RIP configuration mode. Then we would state the version. In this case, we're using version 2 because we want to use subnet masks. And then we write down the networks that we want to be advertised in the routing tables so that the other routers can basically learn these new routes and add them to their table. So that's all we're doing here. Now if we go back to our network, we have network 30, 20, and 10. And this router is connected to router 30 and 20. So then we're going to basically tell the RIP protocol to advertise network 20 and network 30 and make the most efficient routes for that. And then the command we use after that is the end command, and all that does is exit the configuration mode and returns us back to the privileged exec mode. Then we have the last command. This is probably the most important command, the copy running config to start config. And this basically just saves everything and makes sure things don't get wiped up after we restart the routers, and make sure everything, all the changes we made actually stays. So yeah, that's pretty much it. Now to demonstrate that the routing is actually working, let's ping router 3, which has network 20.0.0.2. Let's do that. So let's open up our command line. Ping 20. Amazing. So we have full connectivity. And that's it for my project. If you want to see the full tutorial and guideline for this project, you can see it on my GitHub. And thank you for watching. I'll see you on the next one.